Welcome to Dev Bootcamp Life, the podcast that helps you level up so you become the best software engineer on your team, or we help you level up so you land your first engineering job. This is Juan Lizarazo.
And this is Jared Potter.
And Jared, today I brought the topic. So guess what? We're going to talk about building great APIs. And the reason why I decided on this topic is because our audience, they are full stack engineers, right? These are aspiring software engineers. They're building their own APIs. And sometimes I notice like with my students that they need a little bit of guidance. I mean, they understand how to build them, but it's time to help them level up. Okay. So, of course, before we start talking about APIs and getting into the details, right? I would say let's start by defining really what's an API. That would be a good start, and it also would help with interview questions when people ask like, "What is an API?" Right? So, do you want to start defining that, Jared?
Yeah, definitely. So API stands for Application Programming Interface, and it's kind of a larger, you could say, umbrella term that applies to lots of different things. There's APIs on your operating system that you as a programmer talk to, interface to accomplish certain tasks. But there's also what we're mainly focusing on today of what are called web APIs, how you communicate with other interfaces out on the internet, whatever those connections might be.
Yeah. Okay, cool. Awesome. Yeah, that's great. Yeah. So it's just, an application programming interface and that's it. Awesome. Good. Great definition. So when it comes to web development, right, when we're doing, web apps, you and I, right, we work as a web engineers. So do our audience, right, our aspiring software engineers from dev coding programs. So the type of APIs, I mean, there's different type of APIs that we can have. But one that is very common that we use, right, and it's very popular today and it's being popular since 2000, but it became huge popular like probably in the last 12 years, right? It's REST. So let's talk about REST. I want to mention that. So REST, right? REST is an architectural style, right, that uses existing protocols. So you can use HTTP or other protocols to build these APIs. But for web APIs, traditionally we use HTTP as our communication protocol. And also there's this term called RESTful for RESTful APIs, which is just APIs using this architectural style, REST, but they have, they follow certain principles to get the most out of it, to get the most out of what HTTP and the protocols and everything has to offer. So that's what we're going to talk about today, how to build great APIs, right? And we're going to be talking about REST and RESTful and, and use principles and things that should be taken into consideration when building APIs. And this, I guarantee you, is going to make your APIs better. And it's also going to help you nail your next interview if any of these comes up in your next interview as you're trying to land your job. So regarding RESTful, I mean, besides being an architectural style, I mean, it means representational state transfer. And I think that's it. I don't know. Do you have anything to add to that, Jared?
Yeah, I mean, I think part of that phrase, that representative state transfer, is this idea that state, just to kind of help a lot of the students out there, state sounds like a fancy word, but state really just means data, right? A particular configuration of data. And this data can be sent back and forth between a server and a client to represent that data. You might change the data on your device and then transfer that state to a server to be saved, right? So again, state just means data that's being moved around. Now, one of the primary ideas of RESTful APIs is this idea of keeping your API stateless. Mm-hmm. So Juan, perhaps you could explain a little bit more to students, maybe help define that, like why, if we talk about it being this representative state transfer, but then we talk about wanting our servers stateless, what does that mean?
So stateless, that's one of the key principles to when you're building great APIs and when you're building RESTful APIs. So really it just means you don't want to have a session, meaning that every request you make to your API is going to have everything the request needs to be successful, right? Like if it requires authentication, it's going to include the authentication token or the authorization header. I mean, whatever authentication method it needs, right? If it is an authenticated endpoint. And you can perform the request request, and if you perform in theory, like, I mean, many of the endpoints, for example, the read endpoints, right? If you perform that request 10 times, you should get the same data 10 times. I mean, there's no state, there's no like log into the API and then you perform another request and you are already logged in. There's no such thing, because that's what it means is stateless. There's no persisting state. There's no state in memory in between requests.
Yeah, that's a great succinct answer there. I really like that. I know some of my students have been kind of confused about that a little bit, and I think you did a great job explaining that. So
Awesome.
what are the things about REST and RESTful APIs, Juan, did you want to talk
Yeah.
about?
So to build great APIs, right? Besides, I mean, being stateless, one of the things like we want to talk about is like, let's start talking about like to build a RESTful API, right? It's applying all these different principles and different things. So because we're using the HTTP protocol, right? The HTTP protocol has an specification. I think, I don't remember, it's like RFC 2600 or something like that. You can Google HTTP spec and you will find it. I recommend that anybody out there go and read it. It's one of the things that you need to read at least once in your life so you know what it is about. The specification specifies how to use the different verbs and the different pieces that have to do with the protocol. And it's really good because, I mean, it's like a guideline. Like you, as a developer, you necessarily don't have to follow it to the letter. But if you do, it's going to be more consistent with other APIs out there. So the first thing that I want to talk about is response codes, right? When you perform a request, right? We have response codes, and this is one of the things that I noticed that many aspiring software engineers do not use correctly. So the first thing I want to share about response codes, right? Like use response codes correctly. So we have the 200 response codes, right? So we have 200, 201, you know, different ones. Those mean success. When a response is successful, you use a 200 code or 200 something code. It starts with 2. There's the 300 codes, right? So there's those mean those have to do with redirection. So when something changes on the server or there's a permanent redirection, all right, you use a 300 code or 301, 302. There's different ones, and then there's the 400 codes, which is for errors. So for example, we use a lot 400 for bad requests. So when the request is malformed, let's say the server do not understand it, so that means like the client maybe sent it wrong, or when something goes like wrong, we can use, for example, 422, unprocessable entity. That means that the request was correctly, like semantically correctly, but the server couldn't understand it. Maybe there's something wrong. Maybe there's some validation that didn't pass. So that's when you use 400. And then we have the 500 codes, which is you should never get a 500 on your API. I mean, if you get a 500 on your API, you're doing it wrong. That means that you have to include error handling, and you should always fall back into 200s, 300s, or 400s. You should never have a 500. If you have a 500 code, that's internal server error. That means that you have something that is unhandled. You need to improve your code. You need to make it better. You should never have 500s. So status codes, use them correctly.
Yeah, no, I completely agree with Juan about status codes. They're really, really important to use. I mean, in your standard like Express application, when you normally call response.send, and then in that function call, you pass something back, right? That's by default sending a 200 status code. But there's plenty of times where that's not the correct status code to send back, right? It's a little flag that says, hey, how did the request go, right? The developer can really quickly and easily know how the request went by just looking at the status code without having to read any sort of message in the body or anything like that. And yeah, just to reiterate, if you're getting a 500 back, that's not good, right? You need to change whatever you need on your server such that it's sending back a proper response, right? If the user is trying to maybe create a new document in the database and maybe they had fields missing from it, right? You should send back something like a 400, like a bad request, a bad client request, rather than, the server crashing and sending back a 500.
Yeah, and along that, like we have also response bodies that they complement the response. So they are useful information for the client, or they are useful information for the developer, right? So you can include like a message, right, that expresses what went wrong, right? But one of the key things that I like to tell all my students is that never include a success, false, or success true flag as part of your response body, because that's what the HTTP status code is about. So if you're doing like return your response and you return like is created and you say success true, That's not a good idea, because that means that when you're not using the status codes, so that means that the developer will have to parse that response, parse that true. That true is most likely a string, so then they have to parse it into a Boolean or stuff like that. So avoid having response success true, success false as part of your response body, because that's already what the HTTP status codes are doing.
Yeah,
So Jared, what would be another principle, another good practice to build great APIs?
definitely. So one of the most important things about building APIs is a certain sense of security. So, and I'll be really succinct about what I mean by this. So if there's data in a database that's sensitive, this is things like account details about your user account, or maybe if this is Amazon.com, your order list, right? All of this stuff is considered sensitive data, and you don't want just anybody being able to access it. So when you're defining your endpoints for like your get endpoints for account details, you need to make sure that you are checking some sort of authentication token that's coming in, and make sure that it's valid. If it's not, you need to respond with a correct status code of something like 403, not authorized, to say, hey, you don't have access to this data. You don't want your data to just be available for anyone out there to get. Similarly, on the other side, when you're creating new data, you want to do this thing called input sanitization and input validation. So what I mean by this is, when you get a request in from a front end, and let's assume you're building this in an Express API, which I know many of our listeners are very likely going to be using, you're just going to get one big JavaScript object. Not JavaScript object, but a JSON string that you then turn into a JavaScript object. And it could have all sorts of different data and fields on it that the user sent that you don't actually care about, or that you don't have corresponding fields for it in your database. Well, you need to make sure that all those fields coming in, all the required ones are there, they're present. And then of all those fields, what kind of data type are they? Is it a string? Okay, if it's a string, what kind of minimum length do you need? Is it a number? Well, maybe you have a range of numbers that you only allow, right? So you as the engineer need to be performing all of this validation on these requests as they're coming in before you're committing them to the database. Because if you're just using something like MongoDB, which you can literally just take the object in and just throw it right into the database, that's not good. You need to make sure that you're one pattern I've shown my students is you're basically going to create like an empty object, and then you're going to basically have a bunch of if conditionals checking, hey, does this property exist and is it valid? Yes. Okay, then append it to this object that will then actually go into the database. And last thing I want to add about this is that some students might think, well, wait a minute, I've already validate my fields on the front end. Why do I also need to validate them on the back end? And I'll actually let you answer that question, Juan. Why do you have to do it on the back end if it's already being done on the front end?
So you just open the door to other good practices for building great API. So one first thing I want to correct is so 401 is unauthorized and 403 is forbidden. So regarding never grab just the response body and throw it in the database, because sometimes there's extra fields that we send by accident. You don't want to store that in the database. So always clean up your inputs and always validate, right? Whatever is required, the length, all that stuff. The reason why we want to do it in the backend is because usually the API is the one that is in charge, that layer is in charge of the business logic. You don't want that business logic, at least not most of it, on the client. Why? Because the client can be bypassed, can be changed by the end user. For example, I can open my DevTools in my browser. I can make changes to the markup or add some JavaScript, right? I can bypass validation. I can see what request I'm sending to the API, then I can replicate that request. And if you're doing the validation just in the front end, I can bypass that easily, and then I can start creating bad records in the system, in the API, and that's how systems break. So usually the good practice is you want to have that validation in the API, and you also want to have validation in the front end. So is the two types of validation. So the validation in the front end is valuable because you won't be sending requests every time you're trying to send the data, right? So you are saving requests, you're reducing chattiness. But once you send it, it's kind of like, okay, backend, you do the last check and you tell us if these can actually be persisted or changed. So you opened the door to discuss some things here. You talked about request types and you talked about authentication. So let's talk about request types. One good principle about RESTful APIs is using the verbs correctly. So back to that spec I was talking about, we have what's called CRUD, right? Create, read, update, and delete. And these requests, each of them, usually we associate them to an HTTP verb, right? So for gets, for example, we use the HTTP get for read, right? For creation, for create, we use the post traditionally. For update, we usually use the put or the patch, right? So we use put and patch. The difference is like put requires the whole entity. Patch, you can just send the items you need to update on an entity, use the attributes. And then delete, to delete an entity, to delete an entity or an entry in a resource. So that's, yeah, so use HTTP verbs correctly. Well, the advantage of it is like you can just have a single resource representation. So with REST APIs, we have a resource and the resource is represented by URIs, right? So we have a full URI and that URI, for example, is http something.com/API/v1/cars, right? So that's the cars resource. And now with the verbs, we can perform different requests on the same cars resource. We have making changes on the URI, and we can perform a post, or we can perform to create, right? Or we can have in the URI an ID, and then we can perform on an ID a get, a delete, and an update, right? So we're using three verbs, but we're working with the same resource. So that's going to reduce a lot of the URLs you have to manage when you are consuming your API. So yeah, so use HTTP verbs correctly, read everything you can about them and learn how to use them properly. Different engineers use them differently, right? But the guideline, the spec will teach you how you should use them and what responses are expected. Yeah, so what do you think about that, Jared?
Definitely. Yeah, I definitely want to emphasize that, making sure that you are following common standard guidelines for APIs. Like a big part of APIs is that as an engineer, you will very likely be defining APIs. And if you're not defining APIs, you're definitely going to be consuming APIs, potentially third-party APIs. And if we all strive for a certain amount of consistency in how we're creating these APIs, it's going to make it way easier to pick up a new API, quickly learn how it works. If it's using all these kind of standards, again, a lot of them are using CRUD, right? There's nothing that's hard and fast that says, hey, you can't use a post request for getting data. You technically could do it, but should you do it? Probably not, right? Unless there's some specific circumstance of why that might be the case, right? That, stick to the consistency.
It will make it easier when you have new team members or when you switch companies because it's going to be already a familiar common ground. So I'm going to take a pause here and I'm going to go ahead and share our Twitters here. So remember, whatever platform you're listening this on or you're watching this, just follow, subscribe, and to reach out, we use Twitter.
Yep. And everyone can find me at twitter.com/Jared Potter. That's JAREDPOTTER.
Yeah, so tweet at us, tweet at Jared, follow Jared. We have a big follow button there. And for me, you can reach out at twitter.com/Juan Lizarazo G. So that's spelled JUANLIZARAZOG. Click the follow button, reach out, tweet at me, right? Like message me. I have my DMs are open. So yeah, great. Yeah, let us know how we're doing. If you have questions, I have had some people reach out already, message me privately, people that are listening to the podcast. So it's actually really cool to hear from you. Great. So moving on, right? There's something very important about APIs, and this is two things. One thing is the contracts, right? Let's talk about contracts and let's talk about versioning. So these are two fundamental principles that any great API has to have, right? So any engineer that is building great APIs has to keep in mind versioning and contracts. So let's talk about contracts. One of the confusions that I see among my students is that sometimes they ask like, hey, what if the contract changes, right? And that means that there's not an understanding what a contract means. So when it comes to APIs and you have a representation of a resource, right? So the representation of the resource is some sort of JSON, right, with some attributes, right, and that represents the resource that is attached to certain URI, right? So that's the resource. When we talk about the contract, that just means like what keys you have, what values, what data types, right, and what data is required when you create it. Like how do you interact with that resource? That's a contract. What verbs are very available, like can I do a get or can I do a post? Because not all endpoints have the same support for all the verbs. But the important thing about versioning is like contracts do not change. So you don't change contracts. I mean, you could append contracts, like add to it, but you never make breaking changes. If you need to make a change, let's say you have a car endpoint and you need to delete, let's say you had a name and make and model, and now you need to delete the model attribute, you just don't delete it because you'll break your contract. You create a new endpoint using a new version, right? So that's why versioning comes hand in hand with contracts. So contracts do not change. You never say, what if the contract changed? No, the contract never changes. It can change during development. Once it's released, you never change it, okay? And if you change it, you do it as a new version. So you keep both, right? And you eventually deprecate the old one. So for versioning, Jared, let's talk about versioning strategies. I haven't said anything about versioning. So what is API versioning? What versioning strategies do you know or you like using?
So I think you've kind of alluded to it a little bit earlier before, but a lot of API paths will say, we'll start like something with like /API/ and then V, the letter V, and then the number that's corresponding to whatever version it is. So you can have V1, V2, V3, V4. And, just like Juan is saying, and I just want to add kind of succinctly to that, like the idea of the contract is it's like, if you give me this data in this request method, I will then respond with this data, or I will do this thing. And if you don't do that thing, give me that data in a certain way, I'm going to respond negatively, right? So just like in a real world contract, right, as long as all of the conditions are met, you're going to get, what you're expected back. And yeah, once people start building upon that, your APIs, those particular endpoints, you can't just simply change them because you're going to be breaking functionality for those people.
Especially if you have consumers or clients building on your systems. For versioning, so there's different strategies. One is the URI versioning. That's the one we're talking about, like in the resource, in the URI. So /1, /1.1, /v1. I mean, it can be whatever, /version1. That's up to the engineer, up to the company, up to the developer. Other strategies is header versioning. That's APIs use headers for versioning. So now we need to talk about headers, right? But we usually like URI versioning is the easiest one for developers, for consumers. Is the easier to maintain, the easier to consume. So I recommend that one. But header versioning, you see it around with some APIs. It's just that it's not as transparent. So let's talk about headers, Jared. What is a header? Do you know? Like how to define?
Yeah. So in the HTTP spec, there's like basically three or four different things that basically kept track of in an HTTP request. There's the URI, or the URL, essentially, right? And those are mostly interchangeable terms for what the sake of this conversation is. There's the URI. There is the HTTP method. So that's your get, post, delete, update, whatever. And then there is headers. So there's headers, and then on post requests and put requests, there's also a body that goes along with it, right? Now, there's also potentially query parameters, but those are just part of the URL. But those are like the four main things, right? So headers are basically, it's an extra pieces of data that are relevant directly to the request at hand, right? So you might have something like the response type, like what kind of data is coming in. That's really important so that the other side knows how to process what's getting sent back, right? Is it HTML being sent back? Is it JSON being sent back? What is the data type such that the other side knows how to process it? And headers can also be used to pass things like cookies, authentication, cookies, or what have you. There's a long list of different headers out there.
Yeah, no, that's good. That's really good. So in a nutshell, header is just part of the request and it's not as transparent. I mean, it's not part of the body. The body, you can include it with any type of request. You can include a body in GET or in other type of request, but traditionally you don't want to include bodies on read requests, right? You just see it on pause or in patch or put, right? But yeah, no, that's really good, Jared. So So versioning with headers, I don't recommend it. But now that we talked about headers, let's talk about the next natural thing to build great APIs, which is content negotiation. So this is one of fundamental when you're building REST APIs. Yeah, and content negotiation just means that you can have a resource, and the resource can respond, can provide responses in different formats. It could be JSON, it could be XML, it could be HTML, right? So the content negotiation works with two headers. One is the content type that you can send as part of the request, and that you says like what data I'm sending you, Mr. Server, right? So let's say I say like I'm gonna send you JSON. I say my content type is JSON. So that's what I'm sending to the server. But as a client, I can use the accept header to tell the server, hey, if you respond to these, right, and if you support it, please respond in this format. So I could say accept XML or accept application JSON or accept text HTML, right? And it could come back as that format if the server supports it. If the server does not support it, it will just ignore it. Many APIs today just ignore it and just respond with JSON. Other APIs responds to the different format. For example, if you use Ruby on Rails, it will automatically respond with XML or with HTML because it's just out of the box. So it depends how the API is built. But at the same time, because an API is an abstraction layer, it abstracts the implementation details. We don't know what is using under the hood, which is super nice, right? But one of the things like content negotiation, right? Request response, right? So you have the request body, the request, you have the response, right? Body, and you have the accept header and the content type. And that's content negotiation. I don't know if you have anything to add to it, Jared.
No, I think that's pretty succinct on that. If you're building an API that has the necessity to return the data in multiple different formats, then yeah, absolutely, you need to account for that. A
Great.
lot of
So
APIs are JSON typically, but there are other
yeah,
ones out there.
yeah. So Jared, let's talk about, you talked about query strings. Let's talk about query strings. When should we use query strings, and when when should not we use query strings? Let's talk about that.
Yeah, I think that's a really great question. So the most useful purpose of a query string is if you want to be able to basically grab a URL and either share it, maybe send it to someone else, or maybe you want to save it as a bookmark. You're able to basically, somebody else is able to click on that link, and that link contains all the information necessary to load up a particular state on the web page, right? So for example, I could go to Google Maps, create like a road trip from Salt Lake to Las Vegas. I could copy that whole thing in the URL, it generates it all, send it to Juan. Juan can click it and get the exact same set of directions, and all the information is stored in the URL.
And what about APIs? Let's be more specific now in APIs, query strings in APIs.
Oh, that's a good question. I
Because in APIs, we don't bookmark anything, right? It's an abstraction. The consumer does not know about it. So when would be a good practice with query strings, which you already defined, when it comes to APIs?
I think typically the place where I've seen query strings is on GET requests that have basically filtering options. Like I want X number of results. I want maybe you have pagination built in, so I want the fifth page. Maybe you have a sort by field, so you want to sort by the name or the age or what have you. But yeah, typically on a GET request, it's used for adding options for selecting the data that you want.
Perfect. You nailed it. So query strings, how I tell my students to remember query, you're querying data, you're reading data. So the good practice for this is that you just use query strings with get requests. Don't use query strings with post, don't use query strings with delete. I mean, you could, but it's wrong. It's not the intended way. Query is to query data. So just get requests. It's used for filtering and perfect. You nailed it there, Jared.
So what about the other case being when not to use it? What would that be, Juan?
Oh, you never use it if it is not a get, you never use it. Like if it is not a get, you don't use it. Let's say you're creating a resource, you're doing a post and you see a query string. No, you're doing it wrong. It's not a get, don't use query strings. query strings, if you're not clear with that, is when you have the question mark right after the whole URI, you have the question mark, and then you have a like a variable equal and a value, right? So that's when we talk about query strings. In case anybody listening didn't know, but also keep in mind, don't confuse query string with URI params. URI params is more like, let's say you have a get cars/1. That's a URI param. So that's different to query string. So URI params are okay with any type of request, right? Get, post, put, but well, traditionally with post, we don't want to post on a specific URI params. We just want to post on the collection. But yeah, query strings, just forget really. So when not to use it, when it's not a get, don't use it, right?
Yeah.
Just for filtering,
Okay. Good.
or for pagination, right? Pretty cool. So one thing you mentioned, Jared, about authentication. Let's talk about authentication. Now we're running out of time, so let's finish with authentication. Like, what would be a good practice about authentication, or good ways to authenticate? Like, what can we share with our audience?
Yeah, I think there's just a couple of bits that I'd like to add on for authentication. So one of the best, well, the couple of the best practices I would recommend for authentication is one, don't ever create your own authentication. Just use existing authentication solutions out there, such as Firebase or Auth0, or even Netlify has its own authentication at this point that does a really good job. You can use those things. If you are needing to maybe build a more custom perhaps implementation, what I would suggest is making sure that you use things like HTTP only and secure cookies for your HTTP tokens that are being sent down and being saved to the browser. This will make it so that the browser, inside your JavaScript, never has access to your tokens. Instead, the browser is in control of them, and the browser will send them to the server every time they're necessary to be sent. And that's from a data security standpoint, you don't want that there. The other thing that's important, and we're not going to get deep into it today, is CORS, or cross origin resource service or server, something like that. I can't remember. But most developers just find this really annoying and they just turn it off and then they move on with their life. But in a production world, when you are deploying to a production environment, you absolutely want CORS on. And really what it's doing, the short version of what it's protecting from, is it's saying, I will only respond to requests from certain domains. I don't want to just receive requests from anywhere. I only want to receive them from a certain set of domains.
Yeah, it's a way for the developer developing the API, for the API to tell the browser, hey browser, if it is not coming from certain domain, don't reply. Because if it is not the browser, it's bypassed, right? But it's a way to like establish the context for the browser. So something very important for production APIs is also use HTTPS. I mean, if you're on production API, you gotta use HTTPS. If you're not using HTTPS, you are doing it wrong. So yeah, no, that's pretty good. I wanted to add to the authentication part, Jared, for strategies, right? So either use, I mean, you can do basic authentication. I don't recommend it because that involves sending the credentials on every request, right? Encoded with base64, not ideal. So most commonly we use tokens today, JSON web tokens. So read everything you can about JSON web tokens. They're spelled like JWTs. They're pronounced like JAW tokens. Whatever way you like to use it. I just call them JWT because I'm a foreigner. I can get away with it. but yeah, so research about that. So Jared, you wanted to add something?
Yeah, one last thing, and this just goes back to the point about saying I highly recommend people just use a auth solution rather than building your own. But don't ever store a user's password in your database. Just don't do it. Don't ever do it. Even if you're trying to just maybe build like a test project or something, you don't know if that project might turn into something real. Don't store users' passwords, right? Even if you hash them or things like that, it's just better to use a solution. So just want to emphasize that. Don't ever put a user's password in your database.
Yeah, you delegate that responsibility to the third-party service for authentication or authorization. So there's Cognito in Amazon Web Services. In Google Cloud, there's like Firebase, right? Firebase authentication. I mean, there's so many options out there. But yeah, always delegate to that and let them handle it for you, and they will provide you with a token that you can use in subsequent requests on your API. So I think pretty much we covered like how to build great APIs. I think we covered most of the good principles there. So let's do a quick recap, Jared, to finalize the today's episode. So we talked about API, REST, right? The architectural style, RESTful. We talked about stateless, URIs, sessions, CRUD, verbs, right? All the HTTP verbs, status codes, headers, contracts, versioning, authentication, query params, content negotiation, and third-party authentication. What else did we talk about?
There was input, validation, and sanitation, making sure that you're controlling what's coming in. Clear documentation, make sure that your contracts are really clear between the front end and back end. I think
use Swagger. Research everything you can about Swagger. That's a good way to document APIs.
Yeah, and otherwise, I think that's everything.
Awesome. Thank you so much. So so that's it for today. Thank you for joining us on this episode of Dev Bootcamp Life. This is Juan Lizarazo.
And this is Jared Potter.
And we'll see you next week. Thank you.
Take care.